Right. So last class we finished up everything concerning linear graphs. We looked at everything, gradients, equation of line, y-intercepts, everything. I don't remember. I don't remember all of it right now, but we finished that up. And now we are looking at, oh yes, parallel lines, perpendicular lines, and so on and so forth. So now we're going to move on to curves, right? Parabolas, or as they're called. So let us get straight into that. So I gave you guys 4 graphs to plot. And I did make the point that they would, just to give you a heads up, that you don't get too surprised when you draw the graph and it don't come out as a straight line, that they would not be a straight line, that they would either be a smile or a frown, a smile or a frown, all right? So they will be curves. So I'm just going to use one of those graphs, one of those equations to make the point in our lesson today. And then you would be expected to do the same for the other 3 graphs, because I gave you 4. So let's go ahead, let's start. So I gave you to plot a graph for the function f of x is equal to x squared plus 2x minus 3, right? So I'm sort of going to be working 2 ways here, because I want to make a very important point. But before we do that, let us just solve this. Let us just plot the graph for this one, right? So we were given the domain values, -4. So it was supposed to be for -4 greater equal to or less than equal to or less than -4, and then equal to or less than +2. So we knew that our domain, our x values would be between -4 and +2. So what am I doing? So just let's work out for that. So this is not going so good at all. All right. So our x values will be -4, -3, -2, -1, 0, 1, and 2, right? So those are the x values that we got here in our domain. That's what I just put at the top right there. So those are the x values. All right, so let's work out now what the corresponding y values are, since we have the function. So let's do it for -4. So f of -4 is equal to -4 squared plus 2 times -4 minus 3. -4 squared would give you 16 plus 2 times -4 is -8. Just put that in a bracket. Minus 3. And then 16 minus 3 minus 3 would give you 10, +10. I think so. 16 minus 3, well, -3 minus 3 is -6. 16 minus 6 is +10. So we can go ahead and put 10 here for our y value. Right? Next one, f of -3 is equal to -3 squared plus 2 times -3 minus 3. minus 3 squared will give you positive 9. 2 times negative 3 gives you negative 6 minus 3. And you would have for your answer here, minus 6 minus 3 gives you minus 9 minus 9. That looks like 0 to me. So Amoy, you can just double check my math just to make sure that what I'm giving you is actually correct stuff. All right. All right, so there is a mistake here, Amoy. Okay. So it's a good thing I paused to check. So this is 8, is because I wrote it, but I thought it was 6. So this is minus 8 minus 3. That would give us minus 8 minus 3 is negative 11. And 16 minus 11 would give us a 5. So let me just write this 8 properly. So that's an 8. And then 16 minus 8 would give us 5. So right here, we would have 5, right? And then our answer for here is 0. So we would have 0 right there, all right? So let's go on to the next one. F of negative 2 is equal to negative 2 squared plus 2 times negative 2 minus 3 equals to minus 2 times minus 2 squared is positive 4. 2 times negative 2 is negative 4 minus 3, right? So you have 4 minus 4 is 0. Minus 3 is going to give you, leave it minus 3. So we have minus 3 right here. Right? I'm just going to erase this so that I can have space to work the rest. All right. So we're at negative 1 now. So f of negative 1 is equal to negative 1 squared plus 2 times negative 1 minus 3. That is equal to 1 minus 2 minus 3, which is equal to 1. I just put 1 minus 5, which would give us minus 4 for our answer. So for this one, we have minus 4. All right, good. Next one, f of 0 equals to negative, 0 squared plus 2 times 0 minus, morning, minus 2 times 0 would give us 0 squared plus 2 times 0 is 0. So our answer would be minus 3. So we have minus 3 here. F of 1 is equal to one squared plus 2, no, that's not right, plus 2 times 1 minus 3 equal to 1 squared plus 2. Well, 1 plus 2 equals to 3. 3 minus 3 gives you 0. So we have 0 here. And then for our last one, f of 2 equals to 2 squared plus 2 times 2 minus 3 equals to 2 times 2 is 4. plus 4. Is that right? Let me just double check. 2 times 2, 2 squared is 4. And 2 times 2 is also 4 minus 3 equals to 8 minus 3 gives you a 5. So we have a 5 here. Everybody good so far? Is Amoy alone? So we have our table here. I'm just going to graph it, just to bring up the graph and show you. So these are the things that we're going to be wanting to accomplish today with each and every one of your graphs. We're going to be looking at solving a quadratic equation graphically. And I say graphically because we've already done quadratic equations and solving quadratic equations. And when we did so by 2 methods, one which was factorizing, and the second method which was using the quadratic equation. Now we're going to be learning how to solve a quadratic equation graphically. We're also going to be looking at some properties of this of these types of graphs, graphs that come as a result of using a quadratic function, namely the maximum, the minimum, as well as the line of symmetry. And then we're going to look at finding the maximum and the minimum and the line of symmetry without using the graph. So if you remember last week, when we did linear graphs, we could find the y-intercept, for example, and the gradient with or without using the graph. This is the same thing this week. We're finding the minimums, minimum or maximum, as well as the line of symmetry with and without using the graph. So let's start with number 1, which is finding our quadratic equation. I'm solving our quadratic equation. Before we go there though, I'm going to have us solve this first question regularly, or we're going to solve it together because I suspect that you may not quite remember how to solve quadratic equations with the factorization method. So we will do that together. So this same question, 2x plus, no, that's not right. What am I doing? X squared plus 2x.
X squared plus 2x minus 3.
X squared plus 2x
Minus
minus 3. All right. So when we solve these equations using factorization, we usually find two numbers that when you multiply them, together, the product of them is equal to AC, which in our case, A is 1, because there's a 1 here, and C is -3. So when you multiply them, you should get -3. And when you add them, those same two numbers, you should get B, which is +2. Remember this?
yes, yes.
Or we solve it? So tell me what those two numbers would be now.
Would be 1 times -3.
Other way around, -1
Yes,
times +3, because when you add
yes.
them, if you use -3 and +1, when you add it, you're going to
Going
get
to get 4.
-2.
Yeah,
So if you
negative.
use, right, so -1 times 3 gives you -3. And if you add -1 and 3, you would get a +2. So these are the two numbers that we are going to be using to solve our equation. X squared, so you would just put in this, which is -1, 1x, or I can just call it x, right? Minus x plus 3x. Those are the two numbers that we just found, minus 3. And then we would go ahead and we would factorize by pairs. Yes, we would factorize this pair together. You remember all of this?
Yes,
Huh?
miss. Yes, miss. So,
Right? You'd factorize, no, this together and that over there, so together. So let's go ahead and factorize x squared minus x. What would we get?
you would have x outside and x minus 1,
Okay, and now we're doing positive 3x minus 3. We know we
and then
need to have the
same
same
thing,
thing inside,
x and outside 3.
outside 3. So our answer for x, well, let's factorize again. X plus 3, x minus 1. So our answer, just put equals to 0. So we're solving. Right, so our answer would be x plus 3 equals to 0. That means x equals to minus 3. And our other answer is x minus 1 equals to 0, which means that x is equal to positive 1. So our two answers here, because remember we've always said that when you solve a quadratic, you will have two answers. So our two answers here is x equals to negative 3 and x is also equal to negative 1. This is using the factorization method. But if we should use a graphing method, no. So I'm just going to where we plot our graph here. So this is the same graph that we just worked out the functions for, right? So this is our graph, and if you notice, it is a curve. And we just, right, if we notice it is a curve, so just zoom it in like that. Oh, it's all the way. All right, so you should be able to see it. Nice, no. Great. So when you are solving an equation, a quadratic equation, using a graph, so when we did it a while ago using the factorization method, we got two solutions for x. X is equal to minus 3 and x is equal to positive 1. If you are to use the graphing method to solve this same equation, all you would do is read off the x-intercept. So where the curve cuts the x-axis, right? So if you notice right here, are you seeing where I'm circling? Right here?
Go to
If you
bottom.
notice, right,
Bottom
no,
of,
right here that I'm touching. Are you seeing it?
yes. Yes, at the bottom of the curve.
No, man, that's at the bottom, right up here. So where I touch on it.
Right here you have the black dot.
Yes, right where I have the black dot. So right here, you will see the coordinates of this is negative 3 and 0, where negative 3 is x. This is where, and if you just look at the graph, you'll see that the curve cuts the x-axis right here at negative 3. So this
Yes.
would be one solution. X is negative 3 right there. And then the other solution now would be the other part where the curve cuts the x-axis. In this case, that is positive 1. And you can see that that's 1 and 0, the coordinates of that. So all you have to do to solve a quadratic using the graphical method, you do what you normally do and draw your graph, and then you read off where the curve cuts the x-axis. Because remember, when you solve for a quadratic equation, you're getting an x, two x values, and those two x values is where the curve cuts the x-axis. Understood?
Yes, ma'am.
Right. So this is it. 1 for this part of it, for this cutting right here, and negative 3 for this one over here. So those would be the two the solutions. And it's the same as you can see for when we worked it out using the other method, the factorization method. Clear?
Yes, ma'am.
So let's just do one more. Let's do the second one, just to make sure we're understanding. Our second question said, oh, sorry.
3 plus 2x minus x squared.
3 plus 2x minus x squared. So we're going to just rearrange this to be in the format, which is the proper quadratic trinomial format, which is x
Minus
squared
square.
minus x squared plus 2x plus 3. And because we're going to be solving it, I'm going to be equating it to 0. So just as before, we need two numbers that when you multiply them, you get AC. In this case, A is -1 here, and the C is 3. So you're looking for something that will give you -3. And when you add them, you get B, which here is 2. So what are those two numbers now? Almost seem like the same as before. Yes, it is.
It will be -1,
And 2,
3,
3, sorry.
1, 2, 3.
All right. So same like the question before. So -1 and 3. So we're going to split this middle term using -1 and 3. So, and I'm going through this particularly for as a refresher for you, even though we need it, because I could just jump to the answer, but I'm just wanting to make sure you're fresh in your memory. It's a good exercise, I think. So we're having -x plus 3x plus 3 is equal to 0. And then we go ahead and we factorize by pairs. So we factorize in that pair first, and then this pair second, all right? So let's go. -x squared minus x, what are we factorizing here?
We have -1.
Let's not use negative.
No.
Look over here, -1 not going to work for over here. So I think you should use
Yes.
-x.
Just x. Yes.
Then that would be x plus 1.
Minus plus 1.
Plus 1, because when you multiply -x by that, you get. So over here, you know that your bracket is supposed to be the same, x plus 1. So you would therefore factor out 3, right? So 3 times x is 3x, 3 times 1 is 3, right? Equals to 0. So then for one bracket, we're going to have x plus 1. And then for another bracket, we're going to have 3 minus x, or minus x plus 3, whichever way you want to put it, it's the same thing, equals to 0. So now we're going to solve for both of these. X plus 1 equals to 0. X is equal to -1. And then for this one now, you have 3 minus x equals to 0. I'm going to take the x across because it's negative and I need it to be positive. So you'd have 3 equals to x. So the two answers that you have here are x is equal to -1 and x is equal to 3. So let's plot that. So this is using the factorization method. X is equal to -1 and x is equal to 3. So let's use a graphical method to see if we get the same answer. What was the function? Minus x. Give me the function, please.
3 plus 2x minus x squared.
Give me it after we rearrange it.
Oh, it would be minus x squared plus 3 plus 2x.
Hold on. Minus x.
Minus x squared
Squared.
plus 2x
Plus 2x
plus 3.
plus 3. All right, here we are now. So this one is a little bit, so I'm just going to zoom out so you can see. So let me I just want you to see the intercepts for now. So the blue one is the second graph, right? So we got for our answer, x equals to -1 and x equals to 3 here, where we factorize. And if we were to do it via the graph, we would see that we would just ask ourselves, where does this curve cut the x-axis? The x-axis is the one that runs from left to right. And we can see cuts it here, which is -1. You're seeing that? Where the arrow is pointing. So it cuts it at -1, where the black dot I put it a while ago. And then it also cuts at positive 3 right there, which is the same answer. So this is how you solve a graph using, this is how you solve a quadratic equation using the graphical method. Are we clear?
Yes, miss.
All right, great. So we're going to be using these two graphs now as our prototype going forward, right? So the red one is number 1 and the blue one is number 2. So let's get back to this. So we've done number 1, which is solving a quadratic equation graphically. So now let's look at finding the maximum and the minimum using a graph, right? Now, the first off, a quadratic can only have either a maximum or a minimum. Now, let's say I have, sorry, let's say I have two different Cartesian planes here. Right? And I have one that goes like that, like the one that we just drew, and one that goes like that, right? Now, the maximum and the minimum has to do with what I like to call, simply put, the belly of the curve, right? The belly or the dip of the curve. So it's either you're going to get a hill, which is like this, or a valley, right? If you have a hill, then you're going to have a maximum because it's going to peak somewhere. You follow me? You follow?
Yes, miss.
So if you have a hill, if you have a smile, if you have the one that is turned up, the curve that is upright, then you're going to have the top of it is going to be the maximum, right? The highest part, the peak, is going to be what we call the maximum. But if your curve is a frown or a valley, then the lowest part here would be what we call the minimum, right? So you can only have either a maximum or a minimum for your graphs. You follow me? So, and it all depends on whether it is a smile or a mountain or a frown or a valley, all right? So let's look now at how you find the minimum on the graph. And again, it's simple as reading off a number of the graph. So all you have to do is when you look on your graph, you look on the highest point and then you extrapolate it to your y-axis, right? Because remember your y-axis runs from top to bottom. So this is your y-axis is going to be of concern. So you find, so you're seeing where I have the arrow here?
Yes, miss. At 4.
So
Positive
this is
4.
right. So this is that point here. And if I carry it over to the x-axis, to the y-axis, it is 4, positive 4. So that means that my maximum is positive 4. The maximum for that graph is positive 4.
Positive.
Great. And all I did is just to look at the graph and then just to check and see where the in a moment, where the highest point is and what is the y value for that point, right? Then we can do the same thing with this one, which is our first graph, the red one. Let me just put it right up, right? So that's our red graph. Our red graph now is a frown. It has a belly, right? It's a valley. So you look for the lowest point, which is right here. I've put it in that black dot there, and you can see that it is negative 4, right? It is negative 4. So that is that's just how you find it. Is on the graph, it is as simple as that, right? So you find the highest or the lowest point, and then you read off what the y value, what the y coordinate for that point is, and that's how you find your maximum or your minimum. You can only have one per curve. Is either you're going to have a maximum or a minimum. It's a maximum if the curve is a mountain, right? If it's a mountain, right? Or a frown. It's a minimum if your curve is no, yes, it's a minimum if your curve is a smile or a valley, all right? Another thing I want you to just bear in mind, just for observation purposes right now, is that your maximum value is more often than not a positive value, right? Whereas your minimum value is usually a negative value. So when you look here, you see the maximum value here was +4, yes, and the minimum value was -4. So your maximum value is usually a positive number, and your minimum value is usually a negative number. Clear?
So
Any
far,
so far?
so far.
All right, so we've gone through finding the minimum and the maximum using the graph. So now we're just going to do the last thing, which is finding the line of symmetry. Now, the line of symmetry, when you think of symmetry, what do you think about? If I symmetry, what does symmetry brings to your mind?
The, the name is it opposite to it, symmetrical or shape. It is the
It's a
reflection of it.
symmetrical or same or all right, all of those things equal or all of those things, right? So if something is symmetrical, if I draw a parabola, one of those curve, for example, and I would to draw a line of symmetry. I don't know why nothing is not going straight for me this morning, but the line of symmetry would effectively cut the curve in two halves, right? And the left half is going to be symmetrical to the other half. So it's basically the line that cuts the curve in half. Now, when you are taking this off the graph, the easiest way to find it is to find either your maximum or your minimum point and draw a straight line through it, because your line of symmetry usually runs through your maximum or minimum point on the graph. All right, so let's go back to the graph now just to show you what we're talking about. So we're saying that the line of symmetry that we're talking about is a line that cuts the graph, cuts the curve in an exact half, right? So let me just go out a bit to give you some perspective. So you have a curve here and you want to cut it in straight down the middle. The line of symmetry, when you read off your line of symmetry, you're going to give your answer as a one number value, which is an X value. So your line of symmetry, first thing you're going to do, so you're going to see you have your what do you call this now? I found for the second graph, the one in blue, I found the maximum, because that's the first thing. We said the line of symmetry runs through your maximum. I'm just going to, right? So it runs through your maximum. I'm just bringing it up so you can see just the maximum and we can make the point properly, right? So it runs through your maximum. And when you, so initially I said you draw a line through your maximum, but you don't really have to draw a line through it, because most often than not, because your graph sheet is ruled up, you will have that line going through it, right? Whether it's one of the big ones or one of the dark ones or one of the lighter ones. Either way, you can just use your ruler to line up this line of symmetry with your x-axis, and you will say, all you would say is your line of symmetry in this case is x equal 1, right? So your line of symmetry is x equals to 1. That's for the blue graph. Are you following me?
Mm-hmm.
Right. So what that is telling you, when you say your line of symmetry is x equal 1, you're saying if you draw a line through x equal 1 from top to bottom, that is where the line of symmetry, that would cut the graph completely in half, right? That's right, great. And you do the same for, we can do the same for our first graph. We find the minimum in this case,
with
because it's a
negative
round.
1.
And then we draw the line right through it, and we see it's -1. Another thing that you can see is once you find the point of your maximum and your minimum, right? The
You
y
find the line of
value,
symmetry.
the y value is the value for your maximum or your minimum, and the x value is the value for your line of symmetry. Follow?
Yes, sir.
Because it's the same thing up here. So right there, we saw -4 being our minimum, and x equals to -1 is our line of symmetry. And if we look on graph number 2, we find the maximum. 4, the coordinates at this point is 1 and 4. 4 is our maximum, and that's the that coordinate, and then +1 is x equal +1 is our line of symmetry. So really, if you find this maximum or minimum point, you can therefore get 2 pieces of information from the coordinates of that point. Understand?
Yes, sir.
Great. So I'm going to give you about 10 or so minutes for you to go through and attempt to find these things on your other graphs, please. So you're going to, let me just go back to this. So you're going to solve the quadratic graphically for me. You're going to tell me what's the solution for it. 2 solutions. You're going to find either the maximum or the minimum, and then you're going to find the line of symmetry. So remember we said that for your solution, for your graphical equation, you're going to have an x equal value, 2 x equal values, right? For your maximum or minimum, you're going to have a y equal value. And for your line of symmetry, you're going to have an x equal value. That's how you represent those answers. So I'm giving you 10 minutes for you to do that, and then we will come back. I'm going to check your answers to see, make sure they're correct, and to correct any discrepancies. And then we're going to move on to solving these things without the help of drawing a graph. All right?
Yes, sir.
So 10 minutes. All right, so if we are looking at these 2 graphs, so we're looking at number 3 and number 4. Number 3 is the green graph, 2x plus 2x squared plus 4x minus 6. We're going to look for the solutions for this quadratic equation. And the solutions for it would be where it cuts the x-axis, right? And of course, it has 2 solutions, one of which is, you can see x equals to -3 on this side, and on the other side, x is equal to +1. So that would be the solution for this quadratic equation, x equals to -3, x equal to +1. Now, this graph will have a minimum. So we find the lowest point on the graph, which is this point here that I've put in the black, where the black dot is, and we can read off the y coordinate, or read it off of the y axis, and we'll see that our negative value, our minimum value is -8. To find our x-axis, to find our, well, x-intercept, our line of symmetry, we will see where the, well, we're looking for that line that runs through the minimum, um, and cut the curve into symmetric halves, and that is going to be -1. It's the x value of your minimum, and you can prove it by just taking the minimum, running a line right through the minimum, and you will see that it will cut the x-axis at -1. Going on to number 4, which is our purple graph. If we look, we will see, well, first of all, we can check out to see what this graph is going to be. It has a maximum point. So we can find the maximum point, which is there in the black dot. And the maximum value is a +8. And our line of symmetry will run, if we take our ruler and carry it all the way down to the line of symmetry, it will cut the x-axis at +1. So our line of symmetry would be x equal +1. And the solution for this graph is where the curve cuts the x-axis. It cuts it once at -1, right here, and it cuts it again at positive 3. So the solution for that would be x equals -1 and x equals to positive 3. Right, moving on. So as I was saying previously, we're going to just pause a moment to introduce a concept, and I'm going to introduce it just in a very shallow way today. We're going to spend our entire class on Monday going through completing the square. However, I'm introducing it just to be able to have you apply it to what we're going to be doing today with these graphs, all right? So you can understand the concept of it and why it's important. Because I find that when you teach completing the square in isolation, it sort of get kind of lost because you don't know why you're doing this and what it applies to. And that's the reason why I'm doing it in this way. So I'm going to do it very short-handedly, introduce the concept to you, show you how it applies to our quadratic graphs today. And then on Monday, we will go through in detail how to properly complete a square, all right? So let's go. Now, usually if you have like a regular number, right? So let me just write down some random numbers like 1, 2, 3, 4, 8, 9, 16, right? So where squares are concerned, you can either have a perfect square or a number that is not a perfect square, right? And a perfect square is really a number where, you know, you can find the two numbers that can multiply to give them to you, and they're not decimals or fractions or anything like that. So 1 times 1, so I'm just going to write out 1 times 1 will give you 1, right? Because a perfect square, you know, two numbers multiplied by itself to give you that number. 2 is not a perfect square because, you know, there are no two numbers that you can multiply by themselves to give you 2. So that's not a perfect square. Nor is 3 a perfect square. There are no two numbers you can multiply by themselves. No two perfect integers that you can multiply by themselves to give you -3. However, 4 is a perfect square. You can use either 2 times 2 or -2 times -2 to give you 4, right? So this would be a perfect square. 8 isn't a perfect square, but 9 is, because you can use 3 times 3 or -3 times 3. And 16 is a perfect square because you can use two integers, either -4 times 4 or +4 times 4 to give you the answer, right? To give you. Now, why do I go through this? It's easy for you to appreciate what a perfect square is when it's just a regular number with which you are familiar. When it comes down to algebraic terms and algebraic expressions, it's not that simple. It doesn't jump off the paper to you, right? It's not something that is as second nature as when you're working with numbers. So let's take an example for let's take something for example. When you have the number like an algebraic expression like let's say x squared plus 3x, no, let's do, that's not going to be perfect. Let's do 6x. 6x plus 9, right? Versus x squared minus 8x plus 9. Which one of these algebraic expressions are perfect square? Would you know, just like when you know that say 4 is a perfect square, 9, which one of these algebraic expressions, the A or B, which one of them are perfect squares?
Both of them?
Both of them? What you use to tell what is a perfect square?
What I did, I just said to find the square root of the square of 6, I said 6, 36, and did the same for 9, and also did it for 8x and 9 at the bottom.
You kind of, but the square root of 6 is not 36. The square of 6 is
No.
36, but the square
Square of
root,
yes. Oh. But then again, you couldn't find the square root of to find the square root of 6. You get a decimal.
is not, that's not a perfect square. But
No.
remember that this is an algebraic term, right? So it's almost like, it's a little funny. It's not, the point I want to make is that you're not going to be able to just look at it, at least for now, and tell what's a perfect square or not, right? So because you have to ask yourself what algebraic expression multiplied by itself gave you this right here, right? And just as how you have regular numbers and some of them are perfect squares and some are not, it's the same with algebraic expressions, quadratic trinomials like this. Some are perfect squares and some are not, right? So let's go ahead and look at where it comes from, the origin of it. So let's say I have 3 x plus 3 squared. Now, anything that I get from x plus 3 squared is going to be a perfect square because it's multiplied by itself, right? X plus 3 squared is equal to x plus 3 times x plus 3, yes? And then you're supposed to do the regular thing now. X times x is equal to x squared. X times 3 is equal to positive 3x. 3 times x right here, so positive 3x, and 3 times 3 right there, so is equal to 9. And then you simplify x squared plus 6x plus 9. And we know that this quadratic trinomial is a perfect square because see it up here, so this is how you get it, right? So this is a perfect square, right? But just looking at it like that, you won't be able to tell, right? So let's work another one. And I know you can expand bracket and work it, but I just want you to appreciate that whenever you get a bracket like this, x plus 3 squared, it's always going to give you, or x plus anything squared, or x minus anything squared, you're always going to get a quadratic trinomial out of it. And this is something that we've worked a lot, and usually I don't have to work it out like this to get the answer because of the format. I can just tell you what the answer is, but I usually work it out and expand the bracket for your benefit, for you to appreciate how to expand the bracket, etc., etc. So that's just the point I want to make. This is a perfect square right here, but you're not really so sure. You don't know it just like that, right? Let's try x plus 4 squared. That would give you x plus 4 times x plus 4. You would have x squared plus 4x plus 4x plus 16. That's all. 4 times 4 is 16, yes. X squared plus 8x plus 16. All right? Good now. So you understand the idea of perfect squares. Now, sometimes we are given an expression. So let me just give it that a different slide. We're given an expression that's it's not necessarily a quadratic trinomial or whatever the case is. We're given an expression and we are asked to make it a perfect square. If ever that happens, this is how you go about it. So let us say we have x squared plus 10x. Now, based on what we did just now, we know that, if you're expanding two brackets, two algebraic brackets to give you two algebraic, well, if you're expanding two algebraic brackets squared and they're squared, you're multiplying the same thing, you're supposed to have three variables, right? You're supposed to have your x squared, your bx, and your c value, right? In this instance here, you literally just have your A and your B values, right? Your BX values. So you have AX and you have BX, but you don't have any C. So what really you're doing, if you're asked to make this to be a perfect square, is you're going to have to figure out what is the C value right there, right? Following so far?
Mhm.
So the question is, how do you get that C value? Now, how you get that C value is really pretty simple. And I'm just going to get it, and then I'm going to go back and we're going to pull two things together right now, right? So what we have to find half of the coefficient of x. So we find x. This is x here. Well, no, this is x over here. So sorry. And this is the coefficient of x that I have highlighted, which is 10. So we find the half of the coefficient of x squared, right? So we're finding half of x squared. Half of x is what? 10 times a half is 5. Yes?
Mhm. 55.
Right? 10 times half is 5. And then we're going to square that, right? Which is going to be, is it 25? Yes, I think so.
Yes.
So but we're not going to write it out. So what we're going to have here is, because remember, we're trying to find the C value. So we're going to have x squared plus 10x plus 5 squared, right? That is supposed to give you x plus 5 squared. Just like how before we had x plus 3 squared, that is supposed to give you x plus 5 squared, right? So you have that's your coefficient. And what you would do, well, effectively that is the answer, you know. Effectively that's the answer. 5 squared. You'd work this out. But I'm just going to work out x plus 5 times x plus 5 to show you what we would get for our answer, right? X times x is x
X squared.
squared. X times 5 is
5. 5 is
5x.
5
5
is
times 5 is 5x. And 5 times 5 is
25.
25. So you have x squared plus 10x plus
Plus 25.
25. All right. So effectively, if you are given, so I'm just going step by step to show you. If you are given an expression that has ax and bx, and you're asked to make it a perfect square, what they're asking you is to find cx, is to find, sorry, is to find the c value, which is the value out here, yes? Right? And how you find that value is half of the coefficient of x squared, which in our case is 5 squared, which is 25, right? And that would give us x plus 5 squared. X plus 5 all squared. When you work out x plus 5 all squared, which is this right here, then you see you get back this, which is the same as what we have up here when we found our C value. Am I making any sense at all? Little bit of sense? No sense?
A little.
A little? Are we going to do one more? So what I'm saying is that here, so we know what it looks like when you are having a perfect algebraic expression squared, right? It is x plus something in a bracket squared, and when you multiply it out, it should give you a quadratic trinomial. And we are familiar with a quadratic trinomial. A quadratic trinomial have an a value times x squared, a b value times x, and a c value, right? So I'm saying to you, if you have a question that gives you an algebraic expression like x squared plus 10x and ask you to make it into a perfect square, when you look at it, you should say, this is an incomplete trinomial, because if you multiply two brackets that are squared, you should get something in the quadratic trinomial form, yes? So if you are given it and it's incomplete, then you have to complete it. You are going to have to find the C value, right? Because if you're that's in the case that you're given the AX squared value and the BX value. To complete it, to make it a perfect square, you have to find the C value, all right? So to find the C value, you have to find the coefficient of B. And we know B is this term right here. So the coefficient of it is 10 in this case. And so we're going to find half of 10 and square it. So half of 10 is 10 over 2. That is 5. This 5 is important. Well, this 5 is important because this is the 5 that is going to be the bracket that you're going to multiply, right? So that's why I'm putting it here. So it's half of 10, and then you square that half of 10, right? So I can now rewrite my quadratic expression in a, or I can rewrite this expression in a perfect square format. And that would say, that would be x squared, same as that, plus 10x, same as this. But now I have found my C value to be 25 because I have half of the coefficient of x squared, and that is 25. This is it in the expanded form, the long form. If I want it in the short form, which is the bracket form, I'll just put x and whatever I got for half of my coefficient of B, I put it back here. I got plus 5, so that will be the shortened form, and both of them are the same. Follow? All right, good. So I'm just going to work one more like this, and then now I jump into what we actually need for our quadratic graphs, right? But I needed to understand the concept before I just dive right into what we need, right? So let's work another example. So again, I'm starting back at the point that if you have, and I'm going to use the one that we just did, if you have an expression like that, that is a perfect square. You will get right, because you have x plus 5. This is going to be x plus 5 equal x plus 5 times x plus 5. And this we know is what a squared is, right? You're multiplying something by itself, right? And if we work this out, we will get x squared plus 10x plus 25. I'm going all the way, just again, just to refresh your memory, to tell you that when you expand this bracket, when you multiply it out to get, you know, the expanded version of this square, of this squared, you're supposed to have it in the form of a quadratic trinomial. Supposed to have a times x squared, which is this here. You're supposed to have a b times x. B is the number, the coefficient, and you're supposed to have c, which is a number by itself. That is how you should have it when you multiply it out, right? And get your multiply out a perfect square, right? And it goes back and forth. X plus 5 squared is the same thing as x squared plus 10x plus 25, right? So again, working back way now, we're saying, what if you're given a part of a quadratic trinomial and told to make it into a perfect square? So what if we are given, for example, x squared minus 20x, and you're asked, what do you need to add to this to make it into a perfect square? Effectively, what you're being asked is, what is your C value, right? They want to know what is the C value, what is the value that you're going to have down here. So, follow me? Yes, no, maybe?
Yes, yes.
Great. And so how we find the C value, we find the coefficient of B. In this case, the coefficient of B is negative 20, and we half that coefficient. So negative 20 over 2 is going to give you negative 10. And then you square it, negative 10 squared, that is your C value. All right. So then your answer for
Mhm.
the long answer, which is the expanded version, the trinomial form, would be x squared minus
Minus 20,
20x plus 100, because negative 10,
100.
10, negative 10 is 100. If you're putting it in the shortened version, then it would be x minus 10 all squared. Follow me?
Yes, miss.
Great. So this is in one instance, right? So this is your answer, right? And we're going to go through some of these more on Monday. So what we actually, I want us to actually get to know is what if we are given, an expression that is not a perfect square, but we can make it into a perfect square. So for example, in these examples, we were given a part of a quadratic trinomial and asked to add something to it to make it a perfect square, in which case it was C. Now, in the instance I'm talking, we actually, in this instance, now this example, which is the one that is pertinent to our graphs, we actually get a quadratic trinomial, right? But it's not perfect. And so you can be asked to make it perfect, effectively, make it perfect. And how you do that is what they call completing the square. You complete it, you make it perfect. Yeah? You get it? So that's what they're asking to do. Complete the square, make it perfect, right? Usually they will say they can usually say, they can ask you to simply just straight up complete the square, and you will have to know what that means and what you have to do to complete the square. And we're going to go through the step-by-step process of completing a square on Monday, or they will ask you to write it in a different form, which is the same thing. Write it in the form x plus h squared plus k. So they can ask you to write it in the form x plus h squared plus k. And this is what is important to us when we are doing our graphs, all right? So as I said, I'm going to teach you how to complete the square come Monday, but for now, we're focusing on this. So you see, just like how in the questions before, we were finding the missing, we were adding something. We were adding a c to the expression to make it a perfect square. Here, when you make it a perfect square, you're going to add something to it as well. And this is going to be
Oh,
called k, right? So you're adding
let me
something to it.
see.
Go ahead.
Question. For
Mhm.
this one, you would use a half of 8 of
No, can't,
negative
no.
8, which is
The half, listen, if you can use a half of A,
of negative 8 and add it to 9.
no, you can't do it like that. But I will
Oh,
teach you how to do it on Monday, right? But
oh,
I want you to appreciate. The difference between the one we did before is that the one we did before, they gave us, the question would have given us just
and
this expression, just they give us a piece of a trinomial. They didn't give us the entire trinomial. They give us a piece of a trinomial and they say, look,
oh,
make this into a perfect square. And you would have to add the plus c to it, right? To make it into a quadratic trinomial that is a perfect square. And so you'll have to find half of the coefficient of b and square it. For this now, the question that you get is in a completely different form. It is a trinomial already. Here it is. It is already a trinomial. You see that? Already a quadratic trinomial, but it is not a perfect square. Right? So that's the difference. It's a quadratic trinomial, but it's not a perfect square. And so the onus now, the question is, how do you make it a perfect square? What do you need to do to it, to add to it, to make it a perfect square? You see, when you finish complete your square, and this is what we're going to teach you on Monday, So when you finish complete all of this, your answer going to look like this. It's going to be x plus h, which is like just usually we have x plus 4. So this is just like a number for argument's sake. And you're going to add plus another number right here. So, and together, it is a perfect square, right? You follow?
Okay.
All right. So together, those are perfect squares, right? After you start it out, you flip it, you add this, you add that. I'm going to teach you how to do it. You're going to get it into this format, which is x plus h. H is just a number squared, all squared, plus k. K is another number. And together, it makes whatever you're looking for, it makes into a perfect square. Why is this important to our quadratic graphs now? Why is it important? Now, for every curve that you draw, this value here, this h value here is significant, and this k value here is significant, right? So this h value represents literally your line of symmetry for whatever particular quadratic it represents. So it's literally the line of symmetry. Do you remember like how we find the line of symmetry on the graph? Earlier, this whatever value you get in here, so for your h, that's literally the x value for your line of symmetry. And this k value right here is going to be the value for your maximum or minimum.
Oh. Okay.
So that's why this is important, right? That's why this writing it in this form, completing the square in this form, that is why it is important. So a lot of times you will see questions that say, express a particular quadratic trinomial, write it in the form x plus h plus k. And sometimes they will say x plus a squared plus b. It's the same thing. Sometimes it's x plus p squared plus q. It's the same thing. Recognize the format and know what the format represents, right? So I'm going to just pull it and put it up here so by itself so I can talk about it on a slide by itself. So we have x plus a number squared plus k. This number here represents the line of symmetry for the graph. And this number here represents the maximum or the minimum point for the graph. And maximum or minimum, you will get a number, but number will have a sign as well. And the sign will determine whether it's a maximum or it's a minimum line, all right? It's a maximum or a minimum point, curve, or whatever it is, all right? So are you understanding that so far?
So far.
So far, all right. So now when you have and I'm going to be using, but just the same question that I had from before, x minus 3x plus 9x squared, right? That's the one that we started out with. And we're being asked to write it in this form, x plus h squared plus k. There are two ways to do it. The first way is to complete the square, which you're going to learn on Monday, because it's going to take an entire class for you to appreciate that, right? Because it's a long way. But we're going to use a formula way to solve. That's the second way, using the formula. So I'm just going to jot it over here. So you can use either completing the square to solve it, which is a method people mostly don't like, and it's a little bit longer, or you can use a formula to solve it. Today, we're going to use a formula in the interest of time and to make the point for our graph, but that's really why we're doing this, right? So the formula now to find h, let me get some more colors in this now. What? Why did you betray me? H is equal to b over 2a, right? And I want you to appreciate, remember that the A's and the B's come from, the A's and the B's come from the values here. A is usually in front of your x squared. B is a coefficient in the second one, right? And the C is the last number right down here. So, yeah. So A, H equal B over 2A, right? So that is how you find H. And then K now, which is the value at the end here. K is given as 4AC minus B squared all over 4A. All right. So that is how you find H, and that's how you find B. All right. That's so H is effectively, H will work out to give you the line of symmetry, and whatever value you have, it has to be a negative value, right? So because x is equal to, the line of symmetry is equal to negative b over 2a. So when you find the h value for this, the negative version of it is your line of symmetry. And for k is going to be your maximum or your minimum, right? So I'm going to work h for both of these. I'm going to work out h and k for both of these. I'm going to work out h and k for this example, and then I'm going to plot this function on a graph for you, and we're going to check to see if our h, our maximum and minimum, maximum or minimum, and our line of symmetry is correct. So let's go. So using back the same one, x squared minus 3x plus 9. So we're asked to write it in the format of x plus h squared plus k. So let's find h first. H is b over 2. So h equals to b over 2a. b is negative 3 over 2 times a, which is positive 1. That's equals to negative 3 over 2, right? So make sure you're double checking to make sure that I'm doing the right thing and I'm not making any mistakes, right?
So far.
Right, good. So H is, well, let me find the question.
Negative 3 over 2.
Where did I get this question from? Wait a minute, yes. So H is,
negative 3 over 2, or you put it together decimal?
it don't matter substantively. So I'm going to leave it like that. I think it's the wrong question I'm working on. But anyways, negative 3 over 2. So it's negative 3 over 2. And we're going to take the negative of this. So it's negative 3 over 2. That gives you 3 over 2, which is 1.5 effectively. So that is H, right? I would say H is our line of symmetry. Remember that. K now is equal to, K is equal to 4AC. Let me do K in a different color. K is equal to 4AC minus B squared all over 4A. So 4 times A in our case is going to be positive 1. C is going to be 9 minus B, which is negative 3 squared all over 4 times A, which is 1, right? So 4 times 1 times 9, that's 4 times 9. 4 nines is what?
36. 36.
36.
10 times 36.
36 minus 3, negative 3 times 3 is going to be 9 all over 4. So 36 minus 9, supposed to give you 27.
27.
27, great, over 4. So your K is going to be 27 divided by 4, which is 6 3/4, 6.75, right? So that is our K. So that it is in, I wrote the question wrong, but I'm going to work with it same way. So if we are writing this in the version x plus h squared, let's get a color, x plus h squared all squared plus k squared, we would rewrite it to say this would be our answer now, which would be x plus our h, we got to be 3 over 2, 3 over 2 plus k, which was 6 3/4, or 6 7/5. So then it would mean that this would be our line of symmetry, and this 6 3/4 would be our minimum or maximum. Well, you tell me, it's a positive number, so would it be minimum or maximum? All right, so let's check it out now. Let's check it out and see. X squared minus 3x plus n. I'm going to plot it. Let me just get rid of all of these.
If you can send me the graph, the app that you use to plot the graph.
It's got a desmos.com. Or you can use a calculator on your computer, you know. I'm going to show you. You have a laptop or so?
Oh. Yeah.
I'm going to show it on your laptop computer. Just give me a minute. What's this now? X squared minus 3x. Squared minus 3x plus 9. Where's my graph? Where's my own graph gone? No. Why is it not coming up? X squared minus 3x plus 9. It probably gone off of the thing. Let me see. It's not plotting. I don't know why. Oh, see there. X squared minus 3x plus 9. Let's check what we got. So we had 3 over 2 for our line of symmetry, and the 6 3/4. Well, this is a minimum, because all of it is in the, that's why I say usually, all of it is in the positive something. Hold on, let me just dig it up. Right, so I want to show the 6 3/4 first. That's why I say I'm doing it like that. So you're not going to the entire graph, because I'm maximizing it so that the scale changes. So this is the bottom of the graph right here, and if you look right here, that's 6.75. You see that? So that value there is 6 7/5, which is the same thing that we calculated right here, right, for our minimum maximum value. Follow? See, 6 3/4, which is 6.75, and on the graph it's 6.75. See that? Yes. Good. And then now if we should run a line through that 6 3/4 to our minimum, it would be this line that we carry all the way down to find, see here, hold on. This is our minimum, max there, right there. Carried all the way down. Just want to see the x-axis. So if we follow the line that's on the dot all the way down, and to see where it cuts the x-axis, because we're trying to find our line of symmetry, right in the middle of 1.4 and 1.6, that's 1.5. And if you can see, the x coordinate for that point is 1.5 as well, which is the same thing that we got here, 3 over 2, which is 1.5, 1.5. All right? So if you're given a question like a graph like this, like a quadratic like this, and you're asked to find the minimum or maximum and the line of symmetry. For that, this is the way you do. You can also complete the square, but it's usually much longer. But when you complete the square, it will be in the very same format. You will get it looking just like this: x plus a number, all squared, and then plus another number out here. And the number inside the bracket would represent the line of symmetry, the x value for the line of symmetry, and the one outside of the bracket would represent the value for the minimum or maximum value for that curve. Any questions so far? No, yes? So we're going to be working just some more of these until we finish up class today, because like that's it for our class today. I want to make sure you understand these and all of that, right? So let's go. Let's work another question. So we have x squared minus 8x plus 9, and we're asked to write it in the form of x plus a all squared plus b. Now again, it don't matter what letters they have inside and out, just know that the one on the inside of the bracket is the line of symmetry, or represents the value for the line of symmetry, and the one outside of the bracket represents the value for the minimum or the maximum, right? So let's go ahead. Let's figure out what each of them represents, right? So h is equal to b over 2a, and b in this case is negative 8 over 2 times a, which is positive 1. That is negative 8 over 2. And to find our symmetry, we take the negative of this. So that's negative 8 over 2, which is equal to 8 over 2, which is equal to 4, right? So that is our line of symmetry. And then we can go ahead and find our minimum or maximum, which is that b value outside there, whether it's b or it's k or it's q or it's m, whatever they want to call it, the one on the outside. The formula for that is 4ac minus b squared all over 4a. 4 times a is 1, times c is 9, 4ac minus b, which is negative 8 squared, all over 4 times a, in this case, is 1. 4 times 1 is 4, times 9 gives you 36, minus negative 8 times 8, negative 8 is 64,
all over 4.
all over 4. 36 minus 64 should give you negative something, something. What's that?
Negative
36
28.
minus 64. Okay. So that's negative 28 all over 4. So that's negative 7. So if we rewriting the quadratic now in the form this, which is making it a perfect square, I'm going to just use a different color here. We would have x plus 4 all squared minus 7. This is negative 7. So it would be minus 7. So positive 4 would be our line, x equal positive 4 would be our line of symmetry, and negative 7 would be our minimum value. So let's plot this graph and see if it comes out to be the same thing, yeah?
Okay.
So what it was, x squared minus 8x x plus 9, 8x squared minus 8x plus 9, okay. All right, so let me just, all right, so this is what we have. So let's just check for our minimum and maximum. I'm just going to enlarge it so we can, the scale can be, it's better for us to see the values. All right, so there we go. Can do it now. All right, so there we go. All right, so this is our value down here. That's our lowest point. So as we can see, the minimum is -7, similar to what we got here. That's a -7, and we also got our line of symmetry to be +4. So that's 4 right there. So if we track the line that runs through the minimum point, which is our line of symmetry, it crosses the x-axis at +4, which is the same thing there. Clear?
Okay.
Clear, 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 or no clear? All right, so I'm just going to work one more. And then that should be all for today, just to make sure that we're not, because this is fairly new, so I don't want to, overwhelm us too much today. So let's do it for another one. Let's do it for 2x squared minus 3x and you know what? I'm going to change it. Don't write this off as if. These ones are different, do differently. So we're going to examine them on Monday when we complete the square. So I don't want to confuse you. So let's do x squared minus 6x plus 4. All right, so let's go ahead now. X squared minus 6x plus 4. So we're asked to write it in the format x plus h plus k, h all squared. All right, so let's go. To find h, we're using the formula b over 2a. b is -6 over 2 times a, which is +1, equals to -6 over 2, and then we take the negative of b all over 2, which is 6 over 2, which gives us 3. So h is 3. And then k equals to 4ac minus b squared all over 4a, right? And then we're going to do k equals to 4 times a is 1, c is 4 minus b squared, which is b is -6 squared all over 4 times a, which is 1. 4 times 1 is 4. 4 times 4 is 16 minus Negative 6 times negative 6 is positive 36 all over 4. 16 minus 36 seems to be negative 20, I think, over 4. And negative 20 over 4 gives you negative 5. So our k is negative 5. So if we are to rewrite the quadratic trinomial in the form x plus h all squared plus k, we end up getting x plus our h was 3 and our k was negative 5, right? Which would mean, oh, that looked worse than, which would mean that our line of symmetry is x equal to, and our minimum value is negative 5. So let's just check to see if that is so for real graphically. So this is x squared minus 6x plus 4. Great. So this is it. So minimize it a bit. All right. So we got negative 5 for our minimum and positive 3 for our line of symmetry. So let's get back here. We see if we go to, so negative 5 is our minimum, and we can see negative 5 right there. We can see it also in the coordinate of the point. And we can see if we draw the line through the minimum, we go all the way up, runs through negative, it runs through x equals to 3, and we can see that 3 is also the coordinate for the x value. Clear?
Yes, miss.
Any questions?
So far, just have to do more practice.
Okay, so I'm going to do just one last one, and then I give you a couple to do for homework. All right, so let's go again. Let's do x squared plus 4x plus 5, right? And we're writing it in the form just as before, x plus h all squared plus k. Good. So let's go. Let's find h first. H is b over 2a. B is 4 over 2 times a. A is 1 in this instance. 4 over 2, and then we take the negative of that 4 over 2 equals to negative 2, because 2 into negative 4 is negative 2. All right, let's do k. K is equal to 4 AC minus b squared all over 4a. So that is equal to 4, a is 1, c is positive 5, minus b is a positive 4, all over 4a. A is 1. 4 times 1 is 4, times 5 is 20.
Minus 16.
Minus 16 over 4. 20 minus 16 gives you 4 over 4. So that gives you 1. So now, if we are to rewrite it in the format x plus h all squared plus k, we would get 2. Oh, 2 where?
Oh, I think where we rewrote it is. But you had the positive 4 and then you turn it into a negative 4. Okay.
Yeah, because remember when we are finding, so h, the h value that is in here is we always put the negative of it. So when we find it, we put the negative. So we could put
Negative,
negative
yeah.
b here as well, but we always take the negative of whatever we get on top.
Okay.
Yeah, that's what we've been doing. That's how it works. All right, so x is where am I? X plus h. So h we found to be -2. All squared plus k is 1. K is 1. So then our line of symmetry would run through x equal -2, and then we would have a maximum of 1. So let's check it out on the graph just to see if that is so. X squared plus 4x plus 5. All right, so let's go. X squared plus 4x plus 5. All right, so let me just, so we have a minimum. The graph is, all of the graph is in the positive section. All right, so no, it's not. All right, so let's go. Let's work out what we have here. So the line of symmetry, as we can see clearly, it runs through -2, right? So if you look at it, you can see it goes, it's near to it, it runs through -2, and the x coordinate for the minimum point is also -2, so that corroborates that, and that's what we had here, right? X minus 2, and then 1, that's the y value. If we read it off, or if we take the coordinate, it's 1, and that's the minimum. So that's that. Easy peasy peasy. So you can use either the graphical method or you can use the completing the square method. Bear in mind that this, what we're doing here, remember there are two ways. There are two ways to complete the square. You can work out the values using the formula, or you can do the actual step-by-step completing the square. Today, we have circumvented the actual step-by-step process because I wanted just to get you to grasp the understanding of what the H and the K values mean. So I did go through the long process of completing the square. And I also wanted you to appreciate why you would go ahead and complete a square, because it's a little bit frustrating to do it in isolation sometimes. So come Monday, you will learn exactly how to complete a square. Bear in mind that it's longer than this method, and a lot of times students don't like it. But as I always say, you have to learn the different ways how to go about doing these things, because even though you may have a preference, you don't know what your examiner will require from you, right? So you have to be prepared for everything. Clear? So I'm going to give you 4 more, and I want you to both plot the graphs, and I want you to get the practice of plotting graphs, because you may be called upon to plot graphs and or interpret graphs when you go into your exam. So I really want you to both plot the graphs and to give me the solutions for the x, for the quadratic, the minimum or maximum, and the line of symmetry. And then I want you to use the completing the square method to give me the minimum and or maximum, as well as the line of symmetry. So let's go. All right. So those 3 I am going to give you for homework. So plot the graphs, as well as use the use a formula way, completing the square to show the answers. Make sure when you draw your graphs are labeled. You usually label your graph with the function. So you would put 1, f of at the top, f of x equal x squared minus 4x plus 6. You put that at the top of the graph paper. So make sure you always label your graph. The workout and all of that, you can turn the back of your graph and do the workout, etc., etc., to make sure that everything is together and you're not scrambling for stuff. And that's just the way you usually do it for completeness. So do these 3 for our class on Monday. So that would be it for our class today. Any questions before we go?
Let me read the SBA. Sir, check on the SBA for me. I'll
Yes,
start
sir.
my question.
I'm either going to let me stop the recording. So yes, he did.
He said